So yeah, let's go ahead and get started. So the prior two talks were much more on like the performance of the hardware and how do we interface here. My talk is going to be much more about the agility and the experience of the teams that are trying to develop software in this space. And as a disclaimer, I am a very Spack-oriented person. Most of this stuff will be centered around Spack. A big part of this is because I've been involved in orchestrating Spack-based DevOps for 3 different application teams. And that's really the goal of this, is to say, OK, what's working well? Why are we doing it? And what are some of the common threads? As well as what's the opportunities that are here. So I'm hopeful. I know that there's a lot of different perspectives. And I tried to create a general surface level here of, and not go too deep into different things. But I do acknowledge that many of this is going to be my perspective bias. So I'm going to introduce my background to give you an idea of what my bias is coming into this, as well as some of the kind of scope of the projects that I'm working with. And then we'll talk about what does it look like for these teams in terms of interfacing with Spack and the systems. And then I'm going to have some pointed feedback for people who are systems applications, as well as my own beloved Spack team, for things we can do to make life better for the application teams. OK, so who am I? So a lot of times I joke around that I'm a computer scientist by accident. I studied mechanical engineering. I didn't learn how to write a for loop until I was like 22 or something like that. And in general, this DevOps space that I now find myself in, and in general this space of HPC, is something that I admit I am a master of none here. I am constantly trying to learn. I am ingesting more information. And I don't mind being corrected. Most of the time I know I'm not the expert in the room. But I have been learning a lot of stuff, and it's been really fun. And I think if I could do it over again, I would be a computer scientist on purpose. So how did I get into DevOps? I came in from really a CFD background, a CFD application developer. And in 2019, I joined the Exowin project, which there was a nice introduction to the level of complexity and ambition there. And my first 8 months of it was just kind of hammering between Spack and the complexity of the software. And why am I always rebuilding everything? And why are my builds taking so long? And why is everything so poorly managed? And in general, like, it was a big nightmare for everybody on the team to try and manage the complexity of that stack. We knew that Spack had a lot of answers, but this was also earlier days of Spack. This was pre-Klingo concretizer, pre-many different things that have made life better. But I was watching what was going on here, and I saw some development feature ideas develop, like Spack dev build and Spack develop. And as this kind of formulated, I decided to get involved, and I architected a management system called Spack Manager, which basically led to the orchestration of Exowin's entire build and DevOps infrastructure. And it made a very big difference for us, especially in getting access to and getting started with Frontier. We were fully on to Spack at that point. And the success there really led me into additional programs at Sandia. So Spark is another code at Sandia, and Sierra is a large kind of suite. And I've joined in with those teams to essentially do the same thing there, tailored to their needs. And so the focus of this talk, I want to kind of highlight what is common going on between these applications. There are many more talks to come on this that I will do a plug for continually throughout the presentation. But I'm not going to go too much into details. If you want to know more about the specifics of the complexity of Sierra, Jake Healy is giving a talk on this on Wednesday, and I'm giving one on Thursday. And if you want to know more about how Sandia is trying to wrestle with and unify our approach to Spack, you can see Sam's talk on Wednesday. OK, so let's take a look at these. And we're not going to go into the details of the codes themselves. We're going to look more at them structurally. So as a baseline, they are all C++-oriented codes. They're all focused on CPU, GPU performance, HPC systems, and they're all targeted on big-scale physics applications, high-fidelity simulations. However, the structure of them and their scope is very different. So Exawind is an open source project. There are many distributed products and repos. There are many different teams that are trying to collaborate in an open source sense. As such, and by living on GitHub in nature, they are relatively cheap to clone. I didn't appreciate it until I moved more inside Sandia's fence at how expensive and large-scale things can get. And another thing here is that not all the products are necessarily needed in the environment. Some of them are happy to develop by themselves, and it's not until we do a massive wind turbine simulation that we need to worry about integrating each other. And so as part of this, there's kind of this distributed DIY DevOps, and a big part of the challenge here was getting everybody to work well together. Spark is a single product. It is another CFD application. It assumes they do have some bifurcation within the code, but basically they assume we will always have this structure and this layout when we build Spark. It is substantially more expensive and an investment to clone and to deal with all the data related to that product than Exawind by itself for development. And so as such, people prefer a persistent copy of the source that exists. And I would say the DevOps efforts here, they are assumed by the developers, but they are definitely more targeted and more concentrated than in Exawind. And then in Sierra, it is kind of the combination explosion of both of these. There are many, many products, but one giant mega repo. There is some sub-repo stuff, but generally it is one gigantic build. It is much more expensive than these other two combined to handle the source code. And due to the nature of the software and the fact that it is actually a suite of multi-physics applications, the internals of it are as complicated, if not more complicated, than our TPL stack. So typically you think about things as, hey, I want to manage my TPLs and then build the software I care about. And in Sierra, it's like, that is not really much of an inflection point. And this team does have more resources. It does have a dedicated DevOps team. So what is common here? All three of these projects want to span the emerging space, right? They are growing in size and scope in terms of applications. And as the platforms are getting bigger and more complicated, we want to map into this with as little overhead as possible and as maximum confidence that when we do get onto this system, we can actually get physics results and we can do good science. And I would also argue that at a broad level, pretty much all applications at least in the space that I work in, are very similar. We have some kind of administrative group or work, and basically the net goal of this is to set up build, test, run, and deployment environments that are consistent, they're reproducible, and they're modular. You want to be able to move on to a new system with as little headache as possible, or to switch the compiler and know that you're not screwing up everything. And so the fewer inputs that you have to that process, or the more refined you are and the knobs you expose, the better. And Spack has been really important here because it kind of creates this nice interface where we can kind of deal with lots of different groups and get a lot of stuff out of this. One big group that we care about for applications is the application developers. And they are really kind of a mirror of the administrative workflow. But they are hey, turn off a lot of the knobs. Please just tell me what I need to know to build on this system and what are the permutations that matter for iterating quickly. And I think one thing that is not always appreciated is the sensitivity to latency here. We feel it a lot. I'm going to talk about it more on the HPCs. We feel it a ton on the HPCs. But for a developer, ideally, you are doing lots of fast, small builds and running tests in a very tightly coupled cycle. And the more you're waiting on your process, the more time you're burning on getting results and improving your software. So as I mentioned, Spack here is, if we take a meta programming analogy here, if Spack is this super class of capability, then the Spack environment is really like the instance object of it. It is, hey, let me select what I want out of this. What are the properties here? And I would say that the configuration of the environment is kind of the heart of this whole operation, because from this, you can derive all of the additional operations that Spack provides. So that is what the rest of the talk is mostly going to focus on, is the curation of the Spack environment. And I alluded to this already, but I think it is also worth noting, Spack has a lot of power and availability. I think when we move into the application space, for the administrators, as I mentioned, we want modularity and we want flexibility. We want to start detuning some of the knobs and saying, okay, well, let me reduce the number of commands and inputs that I need to provide to get consistent results across moving from system to system. And so all of these projects have used Spack extensions, which allow us to do something like what is on the right, which is a multitude of Spack commands in a single command, where we can then basically create customization that is machine or platform specific with reduced inputs. And so the administrators do the work of setting up kind of what is the background for this, so that way we can reproduce things quickly. So let's take a closer look at that process. And I'm going to apologize in advance for the next slide, because it is a graph vomit. But I wanted to illustrate this because when we look at these projects, in many ways, they are essentially all doing the same thing with different names. And I'm going to talk about why for the rest of the talk. So I'm going to break it into basically 3 groups. We're going to try to take a macro level and not dive into each one. But there is basically some sort of shell interface that is the starting point for all of these projects. There is a bunch of stuff involved in environment creation, which we'll talk about. And then we're going to talk about building and iterating. I'm not going to get into reporting at all because Jake does a really good job about this in his talk, but the ability to efficiently report our results and kind of assemble them is very important, and Jake will do a deeper dive into that. So let's start with the shell interface. Spack has a shell interface already for those who use it, where you source a file and then you start getting shell stuff. So why are we doing it again for the applications? And if you've seen any of my talks in the past, or if you've worked with me, you may be saying I'm a hypocrite here, because I always say, well, we don't want to wrap Spack, we want to extend it. However, I would maintain that for right now, we do need a shell interface for applications. The shell interface really provides 2 things. It provides us a venue into interactive Spack operations that can change the state of our shell, which for development, when we want to be jumping around into hash-based build directories and things like that, is very important. So things like env activation, build environment, CD, all this stuff. Another thing that has historically been important is environment curation. When you jump from machine to machine, they have little quirks. They have different proxies or SSL certs or things that you need. And so being able to set all that stuff up, it was nice to have an interface for. I am happy to report that due to Sandia's funding and efforts, we have, I think, solved that latter one. Joe Fry here implemented this PR that allows you to set environment variables now in your Spack environments. So when you activate it, you can modify your shell environment. However, we still need the interactive Spack operations because we need to activate our environment to get those shell modifications. There is this thing with Python where it's trying not to mess with your shell, and we want to get around that. So I do think, as a request, I think it would be nice to have a clean way to see Spack extend native shell interfaces. Kind of like the Python extensions, they are very important, but they are not complete. Now, when we get to environment curation, there is a lot that goes on here. I'm going to lump it into 3 basic sections. And basically, they're the configs, which I mentioned. This is the lifeblood, right? This is what says to this machine, hey, here's where my MPI is. Here's what my compilers are. There's adding the roots. What is the software that you intend to build? And then there's marking things as develop, as saying, this is the stuff that I want to be developing and doing incremental builds of. Spack, please treat it differently. And when you look at this, it's kind of like, oh, this is the perfect example. This is really, well, we are all doing the same thing, but actually we're not. Everybody has their own nuances here. And a lot of it comes down to what our default is based off of our structure. So like Exowind and Sierra, this is our config stuff is really our preferences. We use includes to include all of our tool chain stuff, and we do this dynamically. Spark has basically a preset template, which allows them to basically just take that template and build it, and they may modify it. But due to the fact that they're just a single application, they've taken a much more customized approach. And I think overall, I don't know if I want to dwell too much on all the details here. I mean, I think it comes down to a lot of this is the structure. But I think we are very similar, very, very similar here. And I think we're ripe for consolidation at a meta level for package applications. But there is this kind of, this is my code, this is the way I do it thing that we're working through, as well as just getting exposed to new interfaces. Like one thing that I think I highlighted before is, you know, for Exowind, it was cheap and easy to let Spack just clone stuff for you when you wanted to develop stuff, because everything lives on GitHub, it's relatively small. These other codes, we have to have a persistent copy of the source code. And so that becomes a knob that we have to inject into these APIs that we didn't consider before. All right, so one final thing on this process, and then we'll move into some general stuff again. So building software, and I want to make a pointed, it's worth noting the iterate, everything is the same. We'll talk about that. And the build and install, Exowind and Spark are basically the same, and Sierra is different. So we're going to talk about that. So I would say Exowind and Spark have mostly been fine for pure Spack install, this kind of orchestration to do things. Sierra, due to its complexity and just cost to build, needs a more complex solution. We use this thing called dep files, which I'll talk about in my talk, and Kathleen is also giving a talk about how they're going to introduce this in as the dominant behavior for Spack, which is good news for everybody. I'm very excited for that. But I would say, I think it's worth noting here that just the name kind of implies the intent. Spack install is about providing an installation, but for development, oftentimes we care more about the build than the install. The install is a bit of the afterthought. And so for when we're doing actual development, we've found that Spack install is too slow. So some of these abstractions, when we want to use them, they don't quite work the way we want. And pointedly at the HP systems, this becomes dramatically worse because there are some file system dependency operations that occur that just inflame the process. So when a developer goes to run Spack install and it has to go lstat 8,000 files and check things or something like that, you get this latency penalty that is just doesn't work. So we have engineered a solution around it. It is this build environment dive function, which Jake will talk about a little bit too in his talk. But essentially it is just create a subshell that has all of the Spack build stuff there, go to the build directory, and now you can just call Ninja or make natively without any Spack in the way. And it works, but I would say it's a little clunky, and it does require some context switching, which is not necessarily intuitive. And I think Spack has been great for installs. I would like to see us start drifting to focusing on the build if we do want application teams to embrace it for their entire process. I think there is value there in that overall for an application team, if we can basically develop as we are going to test, and if we're going to develop and test as we're going to deploy, it can simplify a lot of things. And that's what makes Spack so interesting for this and for all these platforms. Okay, so let's zoom out. I hope for those of you who are not application people, I hope that gives you a little bit of perspective on at least kind of the space and the goal to some of their goals and their perspectives with using these tools on these platforms. But now let's zoom out and say, okay, let's just take the interface of the applications to other people. for those of you who work in the system space and maybe system administrators or have some kind of involvement there, I would say overall that like the old ways of doing things with like user guides and hackathons are very helpful. I don't want to denigrate them at all. But I would say, like, as I mentioned, the config thing is kind of the heart blood of the operation. When I move on to a new machine, the first thing I have to do is set up the configs for how is Spack going to talk to this and construct my build. And a lot of us are doing a lot of work. We're doing performance profiling, setting all this stuff up. I just think that there are better ways that we could be doing this. Right now, when I get on a new machine with any of these applications, the first thing I have to do is start combing through the modules, the programming environments, the system installations, and start configuring things. And it seems like there should be a better way. If we're using Spack, I think we could have a more direct and seamless way. There have been a few attempts. There's like this Spack configs thing that gets updated, every 6 months or so from 1 or 2 systems, but I don't think it's widely used or adopted. And I think this could be something worth having like a committee or a discussion on how can we come up with some sort of standards. Because it becomes even more of a cost when we go to system updates, when things change. And as we've been discussing, the hardware, software landscape is iterating. And every time that I've had a system update on like Frontier or any of these other machines, there's this question that comes up. Hey, we have a performance regression, or all of a sudden something won't compile. And we have to go through and chase down, was it us? Was it a change we made, or is it something from the system? And if it was something from the system, what do we do about it? What do we do now? Furthermore, there were some nice talks yesterday about containers and containerization. This has been a long-standing request. I don't know the right venues, so I'm going to just project this out to all of you, and maybe you'll continue this in your venues. I think from the hardware and the system side, it would be really nice if before a major system update or programming environment change, if a container was generated, that people could then go back and say, oh, let's do a delta here. And if we could just formalize this process of, hey, here are some, when you make your system available, here's how you generate configs that application teams can use. And before you do an update, leave some post-mortem evidence behind that teams can use to evaluate. I think we would tighten up and improve a lot of productivity across the entire space. So, and then some pointed feedback, I guess, for Spack here. I mentioned this as well already, the file system thing. On the HPCs, I have had users who their first experience trying out new tooling with Spack has been on the HPC, which is a nightmare, because they're like, oh, the first time I touch the package configs, I'm sitting around waiting for Spack to do something on this terrible file system, and it looks like it's sitting there doing nothing for a couple minutes. The other thing I would say is concretization and Spack install are really heavy hammers. We have to use them a lot more than I think we should. I've never had the ability to, like, in an application environment, only partially reconcretize. So we always have to do these expensive operations over and over again. I think that these things would really help with the application side. So this is kind of a summary of my takeaways. I'm not going to walk through them again since I just went through them. I think overall, my goal here is I hope that this has at least shown some patterns, that there is kind of a pattern that I see in the application space that is general and I think could be applied, and I think we need some kind of group discipline to start applying it across more, or the right incentivization. But I think we're getting there. The system side, I don't know anybody who's trying to tackle that problem right now. If you are, I would love to talk to you and start working with you. And if it's something you're interested in, I would also love to talk to you. But overall, I think our ambition and what we're doing in this space and from an application team is growing. My talk on Sierra, we're taking a look at the mono repo space, and we're also migrating some of this stuff. Trilinos is testing it out as well to make it easier for these mono repo large projects to interface with Spack. I think this has some really exciting potential. And overall, there's a lot of commonality in my talk I think there's also going to be a lot of commonality or things that we might see. There's several talks in the conference about infrastructure with Spack, both struggles and success. So I think it's worth thinking about what's common here, what's unique, and what's missing. And if we can kind of come with that and then have a post-mortem on how do we actually take the success we have now and amplify it going forward, I think that that would be a very valuable thing. So thank you all.
Thank you. I actually gonna, claim my, privilege of being up here and ask a first question.
Sure.
How different is your experience, with doing this on the kind of like big HPC platforms, right? The El Capitan kind of clone versus, the homespun clusters, we are running with, just our own software.
Yeah, so I think that is the reason for this. Like, that's the reason why Spack works so well as the orchestrator. I'll use Exowind as an example. The whole idea behind Spack Manager is it does a platform detection process to set the configs. So basically, if I'm on my laptop, I run one command and it sets up a machine-specific environment. If I go to another, it does that too. And so basically, for a little bit of kind of caching work of what is unique to this system, we can really reduce the API. And it's basically, everything is basically the same, except for the nuances of how do you run on the different platform, as well as the performance on the file systems that you have to deal with. Or if there are access issues, like if you're on an air-gapped system, obviously, there's a little bit more work you have to do. But overall, it basically makes it to where me developing on my laptop and then going to Frontier and trying to deploy it, it becomes the same experience and the same operations.